Hi class, let's take a look at a couple of applications. So please take a second and read this problem, and let me start highlighting or actually selecting the parts that we need. Okay, so let me start with this problem, and let me just declare or state the variables that we're using. So in this problem, they're talking about the maximum rate, and in this case, t represents the beats per minute. So in this case, so let me just say let t is equal to the actual heart rate, and then a represents the age. Now, what they want us to find out is the actual heart rate that happens to be 35 for a person whose age happens to have that value. So in this case, they want us to solve the actual formula. T is equal to 0.7 times 220 minus the values of a. But they want us to set the values of t equal to 135. So they want to see whose subject is going to have a heart rate of 135, or in this case, 135 is equal to 0.7 times 220 minus the values of a. So let me just box in the main equation that we're solving, and some of these could end up being really messy. So for this particular one, let me just start by distributing out the 0.7, which is given in the problem, and then we're looking at the following. So on the left hand side, we still have 135. This is equal to 0.7 times 220 minus 0.7a. And let me carry out the multiplication. So in this case, 220 times 0.7, that's going to be a 0. 14 and you carry 1, and 14 plus 1 will be 15 with 1 decimal. So I'm looking at 135 is equal to 154 minus the 0.7a. And the next step to solve this equation for the age, it's going to be to isolate a. Let me start by subtracting the 154, and that's going to give us, let me see, 19. Let me actually do it on the side. So we're looking at 154, and you're subtracting 135. So technically that's going to be a 4. That's going to be now a 14. And that's going to be a 9. 4 minus 3 is equal to 1, and then the zeros. So we're looking at not just 19 because of the sign, so negative 19. So this gives us a negative 19 is equal to negative 0.7a. And then at this point, let me divide by negative 0.7, divide by negative 0.7, and let me rewrite the actual value of a. So the values of a, which represents the age, is equal to negative 19 divided by negative 0.7, which is equal to 19 divided by 0.7. And let me express it as a fraction. In this case, multiply by 10, multiply by 10. And we're going to end up with, in this case, 190 divided by 7. So we're going to have to do long division on this one. So let me do it on the side. So we're looking at, on the long division, well, a 2, 7 times 2 is equal to 14. Subtract the 14, and this is going to give us a 5, and then a 0. So a 7 times 7 is equal to 49, and then the subtraction is going to give us a 1. In terms of the age, they want us to round to the nearest integer. So I'm just going to put the decimal there and then add the 0. So the next value is going to be a 1. So 7 times 1 is equal to 7. Subtract and you end up with a 3. I'm going to stop there because they want you to round to the nearest integer. Since this is a 1, you're going to end up with the values of 27. There's actually more values there, 0.1, but in this case, 27. And let me just rewrite it. A is equal to, or in this case, approximately, we should say, because we're rounding, 27. And then they do want us to express this with a sentence. So in this case, the heart rate of 35 of actually is 135 corresponds to a subject that is approximately 27 years of age. Now, the equation that we have here is in terms of t, and you can see the actual graph. Here's a little bit hard to zoom in, but that's the coordinate point on the graph. Let me actually zoom out. But for this particular one, because of the units, it's a little bit hard to see it. But this coordinate point here happens to be 27, 135. And the line represents the given equation if we were to graph it as y and x's. So if we were to graph it as y is equal to 0.7 times 220 minus a. If we were to graph it in that form, there's your 27. The numbers, the scale is a little bit off. So that's actually it for example 4, the applications of the first problem. By looking at the time, we have enough time to do the next problem. So let me move on to example 2. So take a second and read read this problem. Let me highlight what we need. In this case, they want the minimum score in order to get, well, on the 4th test to ensure a C. And then the C, we're assuming that this is going to be 70%. So let me rewrite it as 70%. So let me start by declaring variables. So let x equal to the 4th score. So the score on exam 4. And then the minimum value to obtain AC, it's going to be given by the following equation. So technically they're talking about an average. In this case, they're mentioning an average. So you would have a 63 plus a 62 plus a 72 plus x, which is the one that we're finding, divided by 4 is equal to, and then in this case, well, this is going to be your C, or a 70. They're looking for a 70%. So let me just rewrite it so that we have the proper value. So 63 plus 62 plus 72 plus x divided by 4 has to equal to a 70. And let me start by adding the values on the top. So let me combine all of those. And I'm getting, that would be 3 and 4, that's a 7. So 7 plus x, and then the second unit, it's gonna be 12. I'm getting 197 plus x divided by 4 is equal to 70. And then at this point, to solve it, we could start by multiplying by 4. And this will cancel the actual fraction. So we're looking at 197 plus x is equal to, that's a 0. I'm getting 280. And then at this point, let me subtract the 197. So we're gonna end up with, in this case, x is equal to, and by doing this subtraction, I'm getting, well, a 3 here, and then we have to borrow, I'm getting an 83. Okay, that's actually it for this one. They do want it in a sentence, your final answer. And we're looking at the fourth score. Would have to be a x is equal to 83 to, well, to ensure a C. That's actually it for this one. The numbers were not that bad. I'll put the other problems on another video.